Welcome to Virtual World Techs. So we will explore the NPN BJT fundamental component in electronics and understood how to transistor works and its amplifier signals. So before going to that, I will be discuss the overview of transistor, bipolar junction transistor, and some key components. Okay, so let's get started. So bipolar junction transistor, why called bipolar? Okay, this bipolar means that the current flow in both direction, okay, majority as well as minority. Okay, that means that's why called a bipolar junction. But moreover, this the current flow in both direction. That means system this device is less stable. Okay, thermal, this means less thermal stable due to leakage current in reverse bias direction. I'll be show in the tutorial how to current will flow in the reverse direction in the demonstration in detail over. Okay, and this is the current controller device. Okay, so let's uh, to perform in this tutorial how to operate and the or discuss in the region mode of operation in the tutorials. Okay, so NPN BJT transistor, this is NPN. Okay, so two N types and one P types in the base region. Oh, you can see here. Okay, so basic structure, this is the three layer transistor is a three layer and three terminal and two junction. Okay, junction 1, junction 2, three layer NPN, and this terminal. Okay, this is the terminal. So now this is the semiconductor device. It's either it may be either a P type or N type, or this is called NPN or PNP transistor as per requirement of design as per the class process. Okay, so this is all majority current as a diffusion currents, and the base current is a recombination current. Okay. Oh, this is the transition section. This is the this is the emitter is heavily doped as compared to other regions. That is main function that region is supply majority charge carrier either electron or hole. Okay, base region is very lightly doped and very thin as compared to other section. Okay, this is the main function to transfer the majority of carrier from the emitter to collectors. And now collector in this moderately doped and the high, there's a large area due to the main current flow in this region. So that's why this region is large, so to avoid the heating purposes, other things. Okay, so this is the basic structure of the NPN BJT structures. So now come to the next point. So no signal apply. Okay, nothing. No have signal. Nothing have signal. Okay, that means equal palladium. Okay, without external voltage on a deflection region in the both region. So it's called a current application factor. You can relate over this. So this is without biasing. So that means current application factor is proportional to the ratio of emitter current to the collector current to the emitter currents. So there the region is that the carried charge is free electron act as an insulator. Nothing will be happen to the current flow over there. You can see in this illustration pictures in these tutorials. Now, a small biasing apply in this transistors. So this is a small positive. You can see clearly in this simulation pictures or diagrams. So you can see the current flow is small VE in forward direction. That means narrow deflection region and allow the electron from the emitter to injected into the base region. This forward of the base current IR, the hole from the base is also injected to the emitter regions, the contributing through the recombination process is done by the injection process over there. So you can see here. So now you can see in the graph the voltage that in base current and the base current voltage and base current apply over, but still no have this, nothing has been changed over there in voltage at voltage. So this mechanism. So now come to the next point. Now, in active region, that means apply the signal more and in the collector direction. That means VCE, and adding the forward biasing junction and the reverse biasing the high voltage VC apply. We see the electron injected from the emitter into the base region are swept across the reverse bias junction into the collector junction, uh, forming the collector current. A small positive decommission is process. So you can see here, so decommission process is done. You can see in the clear in this picture. So how look like the current in the flow by the applying the voltage, and that this is the amplifier the signal waveform. So you can see the how to add the waveform. This is the output waveform amplify over there, but before this modeling biasing, this means nothing have been changed over there. You can see that's okay. So it is clear in this picture. So understood the how to in the small region apply and the active region and the amplification purposes the how to work the transistor as well. Now come to the saturation region. Okay, so this is junction. This collector junction is forward bias and the emitter junction is reverse bias. This is low resistance. Okay, the T transistor is on state, and that means maximum. This allow to maximum current flow in the collector emitters. IC to limit only to extend the circuit. Transistors act like a closed switch, and this is the voltage the very small VC is developed here. That means VC value will be dropped over VCC, that means 0.2 volts, and depending on the which type of material using of semiconductor material. So you can see the graph. So there are nothing have changes. Actually, the voltage of the bit means just 0.2 volt for silicons, and so there, but there are in this region there are nothing. There no have a deflection region. That means no have electric field present in this region. In the saturation region, the both is forward. Why? So you can accumulate the electron over there. So you can see. Okay. Now come to the next mode operation. That means cutoff region. Okay, so cutoff region is this application only for the switches purposes. So this is the both this transistor in cutoff region is switch as well off. So this is the this is reverse decimal collector junction is reverse bias, and the emitter junction is reverse bias. So nothing will be happen. The now in the current flow you can see here in the you can see in the simulation and the how to work over there. So nothing will be happening and the no have current moment over there. So but deflection rays and they converted over the electrons, and now this is the VB in the reverse direction, and the of course transition is off state, so no have current flow in the oscillator in this graph, so nothing will be changed over the these regions. Now this is, you can understand the simulation, the conceptual voltage and current waveform, the bipolar junction transistor. You can observe here, and to what I'm thinking about over there. So the input current, that means IB current, output voltage VCE, and the output current IC. You have already discussed in this tutorial. So how to perform the current and what will be current in the different mode. Now, furthermore, for better visualize current flow and electric field behavior in the BJT transistor, how will be performs? Okay, so you can see here. So this is the emitter, base, and collector current. Sorry, regions. So you can see electric field and deflection, variable and voltage. So this is electric field coming across the projection the axons. So in the cutoff region, you can see here. So it's nothing really happened. No have current flow in this region. Electric field already, but have theirs. Okay, now in the active region, so electric field and the current printed it to the emitter to the base region, so the relative field indicated. So now this is the operation will perform, and now the saturation mode is the electric field, the no electric field present in this region, so all we have to go through there. So okay, now you can see here this active region, cutoff region, but okay. Thank you. Bye. Please like and subscribe for more update.